early humans are play fighting. One suddenly jabs the other directly in the ribs. The reaction is instantaneous, an explosion of laughter, twisting, and kicking. That reaction looks completely ridiculous, but look closely at what his body just did. He violently twists away. He pulls his arms inward to shield his torso. He kicks to create immediate physical distance. Laughter is erupting, but the underlying motor program is executing a tactical retreat. Why does the human body react to a completely harmless touch as if it is under a lethal attack? This anatomical model shows the biological distinction between two types of touch. On the left, a light, irritating feather touch produces knismesis, but on the right, a heavy touch to the ribs triggers gargalesis, a deep, high-alert activation that forces involuntary movement and laughter. Notice exactly where that intense gargalesis reaction happens: the neck, the ribs, the underarms, the abdomen. These locations map directly onto the body's most vulnerable vital organs and major arteries. This geography forms the basis of the ancient combat hypothesis. The theory suggests that ticklishness evolved to train our ancestors. Through safe physical play, children were instinctively teaching each other to protect their most vulnerable spots. It is a compelling explanation for our behavior, but we need to see if modern science actually supports it. We can test this defense theory with a universal paradox. If tickling is a physical reflex, why is it impossible to tickle yourself? Looking at this schematic of the brain, we see a process called sensory attenuation. Your brain acts as a prediction machine. When you reach for your own ribs, your brain simultaneously sends out a cancellation wave. Because it knows the touch is coming, it preemptively mutes the sensation. But let someone else initiate that touch, and the prediction system fails. There is no internal warning. The external sensory signal bypasses the filter and registers in the cortex as a massive, high-salience alarm. This reaction requires a complex neurological evaluation of an unpredictable external touch. Having a system designed specifically to detect unexpected contact and force an immediate reaction aligns closely with the idea of an evolved defense mechanism. To see if this physical training tool exists beyond humans, we must study comparative biology. We need to know if other mammals use physical play to trigger similar defensive reactions. They do. In studies of rat behavior, researchers found that playful tickling causes the animals to display positive emotional responses and emit high-frequency ultrasonic vocalizations, the behavioral equivalent of laughter. But while the rats show clear positive emotions, human tickling is frequently ambivalent. We laugh, but intense tickling very often triggers panic and a violent, uncomfortable urge to escape the attacker. This response, pleasure tangled with intense panic, supports the idea of a defensive training mechanism. It feels playful enough to encourage social interaction, but alarming enough to force you to practice escaping. Between the neurological alarms, the animal play data, and the panic response, the defense hypothesis looks airtight. Despite these parallel lines of biological evidence, modern science does not accept the ancient combat hypothesis as a proven fact. In recent peer-reviewed research, the true evolutionary purpose of tickling remains classified as officially unknown. The evidence is compelling, but it is circumstantial. It cannot prove historical intent. This evolutionary tree illustrates competing possibilities. Ticklishness could facilitate social bonding, be a mechanism for developmental learning, or a random glitch in our sensory prediction software. Evolution rarely builds a system for a single reason. It is likely a tangled multi-tool of all these functions. It leaves us with a critical lesson about biology. A highly plausible evolutionary story is not the same thing as a proven scientific fact. Today, our environments have completely changed. We live in a world of smartphones and cities, but our brains are still running this ancient, unresolved program during everyday social play. We know exactly how the brain's prediction software fails when someone else touches us. We know how our bodies physically react to that contact. But the true reason why this sensory software was installed in the human body remains lost to history.